चेक 1 2 टेस्ट ऑडियो चेक चेक 1 2
सर लाइव कर दिया है, ऑडियो वीडियो सही है।
चेक 1 2
10 मिनट पहले हमें टेस्टिंग हो जाएगी ना, सारी क्लियर। हाँ साउंड ही चलेगा सर, फ्लूट साउंड चलेगा। माइक पे बोल आएगा सर, आया आ रहा है, मैं चेक कर रहा हूँ।
चेक चेक
हाँ फ्लूट चला रखी है सर अभी, फ्लूट। ठीक है
आ रहा है ठीक है।
ठीक।
हेलो हेलो चेक 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 टेस्ट चेक 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 वो माइक है ना यार ठीक है।
एक बार वहाँ से भी एक बार बोल दे तो सारे मैच चेक।
चेक चेक हेलो हेलो ऑडियो टेस्ट 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 हेलो हेलो चेक चेक
भैया इसको खोल दीजिएगा, ये वाला जो है ना, ये जो है ना, ये डाइस पे चढ़ने वाला, इसको ओपन कर दीजिएगा। हाँ
कोई हाइड ऐसा ना।
हाँ हाँ हाँ, ऐसे तार लगा हुआ था ना, इसलिए यहाँ से आवाज़ कैच कर रहा है,
ठीक
बहुत
है।
आवाज़ कैच कर रहा है ना।
ऑन है ना अभी।
अच्छा हेलो हेलो हेलो, वॉइस इज़ फाइन? नो? अच्छा ओके।
Prachikito Manisha Tvam Rajishta Manu Neshi Panatham. O moon, we should be able to know you through our intellect. You enlighten us through the right path. The ancient Indian scripture Rig Veda expresses the profound human curiosity about science and acknowledges the moon's role in addressing some of the most pressing questions in planetary science through the Sanskrit shlok quoted above. A very splendid and invigorating morning to our esteemed chief guest, revered intellectuals, spirited participants, dear colleagues, and distinguished guests. Today is a colossal day we welcome with open hearts and curious minds. Today is a vibrant day that invites us to blend the melodies of Indian space exploration. Today is a remarkable day that illuminates our path towards weaving the grand tapestry of our national responsibility towards Vikasit Bharat. We are gratified and honored to witness the magnanimous presence of the Honorable Chief Guest, Professor Anil Bhardwaj, Director, Physical Research Laboratory, Ahmedabad, and esteemed dignitary, Professor Virendra Mani Tiwari, Vice President, Publications and Informatics, Indian National Science Academy. With tremendous delight, I now request the Honorable Chief Guest, along with the Vice President, Shri Sunil Zokarkar and Shri R.K. Malhotra, to join us on stage and grace today's magnanimous event. With profound elation, I, Ananya Banerjee, on behalf of Indian National Science Academy, extend a gracious welcome for the much anticipated INSA Distinguished Public Lecture Series to celebrate and witness the first National Space Day. This grand commemoration of the successful landing of Chandrayaan 3 epitomizes the zenith where brilliance converges with resilience and exploration melds with determination. To commence this astounding lecture session, I cordially invite the esteemed dignitaries to ignite the ceremonial lamp symbolizing our odyssey towards enlightenment. दीप ज्योति पर ब्रह्म दीप ज्योति जनार्दनः दीपो हरतु मे पापम दीप ज्योतिर नमोस्तुते, symbolizing the triumph of light over darkness, the ascent of knowledge over ignorance. With our hearts filled with gratitude, I now request Professor Virendra Mani Tiwari, Vice President INSA, to extend the token of gratitude to the Honorable Chief Guest, Professor Anil Bhardwaj. I now request Shri Sunil Zokarkar to present the honorary token to the esteemed dignitary Professor Virendra Mani Tiwari. Ladies and gentlemen, today we gather not only to honor the groundbreaking success of Chandrayaan 3, which achieved a historic landing near the moon's southern pole, now marked as Shiv Shakti Point, but also to celebrate a new chapter in India's space odyssey. This mission marks a defining moment in our scientific legacy, showcasing the incredible precision and resilience of our scientists who have defied the harshest lunar conditions to achieve a milestone that reaffirms India's stature on the global stage. August 23rd now holds a special place in all our hearts as National Space Day. This designation, announced with profound elation by the Honorable Prime Minister, not only commemorates our lunar triumph but also sets the stage for future aspirations in space as we stand at the cusp of a new era with Chandrayaan 4 and Chandrayaan 5 on the horizon. The theme for this year's celebration is Touching Lives While Touching the Moon, India's Space Saga, which emphasizes the profound impact of space exploration on society and technology. विकसित भारत 2047 का उद्देश्य है भारत को एक उत्कृष्ट, विकसित और समृद्ध राष्ट्र के रूप में स्थापित करना, जो समाज की हर श्रेणी के लोगों के लिए विकास के अवसरों को सुनिश्चित करता है। इस दिशा में हमें भारत को वैज्ञानिक और प्रौद्योगिकी के क्षेत्र में एक विश्व स्तरीय नेतृत्व स्थापित करने का लक्ष्य रेखांकित किया है, जो एक सशक्त, सुरक्षित और संवेदनशील भारत की दिशा में महत्वपूर्ण भूमिका निभाएगा। एक उत्साह के साथ जय जवान, जय किसान, जय अनुसंधान। It is indeed my cachet and prestige to now invite Professor Virendra Mani Tiwari, Vice President, Indian National Science Academy, to embolden us with his words of wisdom and weave the tapestry for today's event. Over to you, sir.
Professor Anil Bhardwaj, Chief Guest of First INSA Space Day celebrations, Fellows of INSA joining offline and online, colleagues from INSA, invitees, my dear children, ladies and gentlemen. Namaskar and very good afternoon to all of you. You all know we gather today to celebrate and honor the success of Chandrayaan 3 mission, which led to declaration of 23rd August as National Space Day, commemorating India's achievement in space science and technology, reflecting on the journey that has transformed our country into a global space technology leader. The recent accomplishments of the successful missions to Moon and Mars, which have not only placed India on the global map, but also inspired a generation of scientists, engineers, and space enthusiasts. This day is a reminder of the rapid advancement India has made in space technology, contributing to the fields such as satellite communications, weather forecasting, and remote sensing. Probably many of our young colleagues, the future scientists of the nations, would be part of the endeavors which will let us bring the orbit of the advanced country much before than 2047. The technologies which were developed and adapted by ISRO have laid a profound impact on the everyday life, improving communication networks, disaster management, and environmental monitoring. Celebrating India's first Space Day, probably intended and in fact planned to inspire young minds, many of them present here and online, to pursue career in science, technology, engineering, and mathematics, which is need of the hour for making India progressed country. It emphasizes the importance of curiosity, innovation, and perseverance, encouraging students and professionals alike to contribute to the nation's space endeavor. Space exploration has significant economic and societal implications as well, with the potential for the growth in several areas like satellite manufacturing, launching services, space tourism, and many of the services which are required to be done utilizing the satellite-based and space-based observations. Additionally, space capabilities are important for strategic regions as well as national security and defense. Making these advancements would be very crucial and critical for the developed nation which we inspire to be very soon. Therefore, it has a large number of areas to be covered, particularly in the view of the geopolitical importance. We very much recognize the importance of the satellite-based observations, and incidentally, I and our group had been beneficiary of such kind of data set which are originating from the satellite observations, and we use them for the various geoscience applications, including an understanding of the spatio-temporal variation of water storage over India, which is one of the very important things for our sustainability. There could not be a better way of closing to have the first Space Day celebration at INSA than to have a popular lecture by none other than Professor Anil Bhardwaj, a distinguished researcher in space exploration and director of the Physical Research Laboratory from where the space research started. I would also like to take this opportunity to congratulate Professor Bhardwaj for his recent recognition of getting awarded with Bikram Sarabhai Co-Spar Medal during the Co-Spar Scientific Assembly. In closing, I must reiterate that it is a day to reflect the progress made so far and to envision the future where India continues to push the boundaries of what is possible in the space science and technology. Once again, I, on the behalf of Indian National Science Academy, extend my warmest greetings to all of you on first National Space Day. Jai Hind.
Thank you, sir, for captivating us with your vision, It is undoubtedly revitalizing to witness your expertise and erudition every time. Dear audience, it is my profound honor and privilege to now introduce our eminent chief guest, Professor Anil Bhardwaj, currently serving as Director, Physical Research Laboratory, Ahmedabad, a paragon of excellence and innovation in the realm of planetary science. Professor Bharadwaj embarked on his illustrious tenure at the Indian Space Research Organization, where he became a linchpin in the Space Physics Laboratory at the Vikram Sarabhai Space Center, eventually ascending to the prestigious role of director from 2014 to 2017. His scientific odyssey was further enriched by his distinguished role as an NRC Senior Research Associate at NASA's Marshall Space Flight Center, where his contributions reverberated across the Atlantic. Professor Bharadwaj's research is a tapestry of celestial curiosity and innovation, weaving through missions such as Chandrayaan 1, Mangalyaan, Chandrayaan 2, Chandrayaan 3 and Aditya L1 to name a few. His visionary planning and unparalleled expertise have been instrumental in propelling India's space exploration endeavors to unprecedented heights. With a prodigious portfolio of over 200 peer-reviewed publications and an array of illustrious accolades including the Shanti Swarup Bhatnagar Prize, Vikram Sarabhai Medal of Cosper and the Infosys Prize to name a few, Professor Bharadwaj's work has been illuminated the frontiers of space science. His role extends beyond the confines of research as he has been a formidable force in guiding scientific policy and practice as the president of the Asia-Oceania Geosciences Society Planetary Sciences, vice chair of the COSPER Commission B and founding president of the Indian Planetary Science Association. With great anticipation and respect, I now welcome our esteemed chief guest to please illuminate us with his wisdom and proficiency. Over to you, sir.
इसको लगा दिया नमस्कार गुड मॉर्निंग एंड गुड आफ्टरनून सुप्रभात और सुअपराह्न और आज के इस ये लाइट्स प्लीज़ ऑफ कर दीजिए सब खाली ये नीचे की बैक की लाइट्स चाहिए मुझे बाकी सब ऑफ चाहिए लाइक ए थिएटर बिकॉज आई एम गोइंग टू शो यू समथिंग which will be like a movie because I am going to take you to a journey to the moon, and as we all know that we are celebrating the National Space Day. ये वाला लाइट्स भी ऑफ चाहिए सामने वाला जो फ्रंट में इसके ऊपर आ रहा है and as you see that the theme of this first National Space Day is touching life while touching the moon, and it is through the Indian space saga. So today we all will be touching the moon by a journey to exploration of the moon and how India has been doing in it, and also to tell you what has come out in terms of the science of this. ये सामने का 3 लाइट जो है फ्रंट वाला वो ऑफ चाहिए बिकॉज वही स्क्रीन पे आ रहा है. इसको आप डिमी रखें अच्छा रहेगा थोड़ा, बट मेरा सभी से अनुरोध है कि कृपया सोएं नहीं. अगर सोने की कोशिश करेंगे तो बीच बीच में मुझको जगाना पड़ेगा. तो फर्स्ट ऑफ ऑल थैंक्स फॉर सच ए वंडरफुल इंट्रोडक्शन अबाउट मी and briefing me to the audience about me. and to use those adjectives very nicely. I don't know the lady's name who actually introduced me. Ananya. Ananya. Okay, thank you, Ananya, for wonderfully explaining to the audience about me. But now it's my duty to explain the audience about what India is doing about the moon. But before I go to the topic, let me bring to your notice about what is happening within the country as India is celebrating. All over the country, we have a big jubilation or celebration happening, and there are many types of quizzes being organized. You are able to see something over here. You can win 50,000 rupees. Space anthem contest. So this is all there on my government. So it is Government of India which is organizing it. All the kids and of course the adults can participate in this. The other one is this one, where also you can win a lottery to go to ISRO, or even go and visit the launch at Sriharikota, or so you can see it here, it is there on the MyGov or My Government, and anyone and everyone is invited to participate in this. Okay, so let us come to this topic of Indian Lunar Exploration Program, and I will be taking you to the journey to the moon. But before that, let me introduce PRL, the Physical Research Laboratory, and I think I will take the liberty to move around now. So PRL, which you see here on the bottom, the 4 campuses of PRL. There are 2 campuses in Ahmedabad, which is the capital of state Gujarat. Main campus, which is now 77-year-old, and we have another campus which is about 40 years old. We have a campus in Udaipur, which is called Udaipur Solar Observatory. It is in the middle of the lake. This is the Fateh Sagar Lake, and this is an observatory which looks at the sun using the India's largest solar telescope. It is a 50 centimeter telescope. And then we have a campus in Mount Abu, where we have 2 big telescopes, 1.2 meter telescope which is working for last 40 years, and 2.5 meter telescope which recently got commissioned last year. PRL is considered as a cradle of space science in India, essentially because whole space program started under the leadership of Dr. Vikram Sarabhai at PRL. It started in the year 1947. Very soon after India became independent, this laboratory was established by Dr. Sarabhai. And whether you talk about the rocketry program, the launch vehicle program, the satellite program, the balloon program, the application program, everything is started under the leadership of Dr. Sarabhai, which you see over here. And here you are seeing APJ Abdul Kalam, who was actually working with Dr. Sarabhai in PRL, and he was sent to Thumba, Trivandrum, to start the rocketry program. And here you are seeing the Madhavan Nair, who was later on the chairman of ISRO. So when you talk about the rocketry program, the first rocket launch took place in 1963 from Thumba on 21st of November, carried experiment developed in PRL. So PRL continued to do the fundamental research by developing instrument and flying on these initial rockets which started. And later on, if you look at the actual PRL laboratory getting established, the foundation stone laying ceremony was done by Dr. C.V. Raman, the Nobel laureate, in 1952. And 54, this building came up and it was inaugurated by then Prime Minister Pandit Nehru. And currently, it looks like this, and this is the place where I actually sit as the director on the top, on the topmost building, topmost level of this building. PRL has already celebrated 75 years. As India celebrated Azadi Ka Amrit Mahotsav, PRL celebrated through a Vyakhyan series which we called as PRL Ka Amrit Vyakhyan. We started on 6th of August 2021 with a sankalp that every Wednesday at 4 p.m. every week we will have one Vyakhyan. And it continued uninterrupted for 75 weeks. On 6th of January, thank you. On 6th of January 2023, we completed 75 episodes. And now it has become a monthly. Anybody can go into this YouTube channel of PRL and see all the episodes which has taken so far. because we do it online, and that was the time of the COVID, but then it has continued, the legacy has continued, and still it is telecasted live on this PRL's YouTube channel. You must be seeing this logo, right? कुछ समझ में आता है? बच्चों से पूछ रहा हूँ, उसके बाद बड़ों से भी पूछ सकते हैं. एक आंख दिखाई दे रही है, राइट? है ना? और ये क्या दिख रहा है? क्रॉस है, प्लस का साइन. तो ये आंख किस बात की है? हैं? सब कुछ देख रही है. हाँ, बिल्कुल सही बात है, सब कुछ देख रही है. ऊपर वाला सब देखता है, राइट? सो ये जो आंख है, दिस इज द सिंबल ऑफ द सन. और ये जो क्रॉस है, ये सिंबल है अर्थ का. तो सन, अर्थ. नाउ देयर आर टू लाइन्स लाइक, एंड देन दिस ए बिग सर्कल. तो इस सिंबल का मतलब क्या है? आपकी दुविधा आसान कर देता हूं, जिसको हिंदी आती है पढ़े. पीआरएल के अनुसंधान क्षेत्र में समाविष्ट है पृथ्वी एवं सूर्य, जो निम्नलिखित है चुंबकीय क्षेत्र एवं विकिरण में अनंत से अनंत तक, जिन्हें प्रकट कर सकती है मानव की जिज्ञासा एवं विचार शक्ति. राइट फ्रॉम द कोर ऑफ द अर्थ टू द एंड ऑफ द यूनिवर्स. जिनको थोड़ा हिंदी कम आती है उनके लिए अंग्रेजी में, PRL research encompasses the earth, the sun, immersed in the fields and radiations, reaching from and to infinity, all that man's curiosity and intellect can reveal. So this is the meaning of the logo, and this logo was designed by Sarabhai, and he wanted to emphasize that sun and earth are two important aspects of our life, but then we cannot be confined to this. We have to study the entire universe, and that's how we started the space program of the country. And if you look at what contribution PRL has given to the country, APJ Abdul Kalam, who was working in PRL, was sent by Sarabhai to start the rocketry program. Professor U.R. Rao, on whose name now we have a center in Bangalore called Prof. U.R. Rao Satellite Center, the center which develops the satellite of the whole country. He was a student of Dr. Sarabhai, and he was working in PRL as a professor, and he was sent to Bangalore to start the satellite program. Dr. Kasurirangan, I hope many of you must have heard his name, and he is now more famous for national education policy, right? And then of course there are many others who have been directors of various labs, who have been alumni of PRL. They did their PhD in PRL. So PRL has a huge contribution in the national building in terms of doing fundamental science and bringing the country to this level. And the type of research being carried out in PRL is given over here, which starts from astrophysics, solar physics, space applied science, atomic molecular physics, theoretical physics, geoscience, planetary science. But we have a very good program for students, which is the PhD program, where we take students who have done postgraduate and they have cleared their NET, GATE, JUST, any of the national examinations, and we take them for doing research for about 5 years. But those students who are sitting over here may be wondering, how can we come to PRL? Yes, you can also come to PRL. If there are two ways of doing it. One, you can come from your school side to PRL through a program which we organize every year. And the second one is you take science, do your BSc, you can come for internship. Even if you are doing BTech or MTech, you can come for internship for 2 months in PRL. We take students of BSc, MSc, BTech, MTech programs for getting trained for 2 months or for doing your project or dissertations. So anyone can come to PRL through various channels. Otherwise, you can ask your school to send you on a visit to PRL, depending upon it is a 1-day visit or a 2-day visit. We can take you to the entire campus. Now, all lunatics, because it's a program for National Space Day, which is related to lunar science exploration, and I must thank all the colleagues and collaborators and co-workers who has worked in various missions the Chandrayaan 1, 2, 3 series and upcoming missions, because missions is a contribution of work of many, many people together, and no single person can do this. And therefore, we should be thankful right from technicians to the topmost people who work in this kind of dedicated missions for years and years together to yield this kind of results. Let us talk about the lunar missions. So, we had the first mission in 2008, Chandrayaan 1, second mission in 2019, Chandrayaan 2, and then last year, of course, the most successful Chandrayaan 3, which made India the first country in the world to have the landing or soft landing near the south pole of the moon. Chandra means moon, right? Yaan means spacecraft, and that is how the word Chandrayaan is. Okay. Now, I will be taking you to a journey to first, second and third through different pictures and movies. There are no equations, no big text, so you can relax and enjoy. The first mission was in 2008. On 22nd of October, we had the launch. After 16 days of travel, we reached the moon with 11 experiments on board, 3 going for the first time. And if you look at this picture, you see the whole spacecraft loaded with experiments, which we call as payload, pay and load, that is how the payload. And you see at the top a grey box, which is called Moon Impact Probe, MIP. And this was released after we reached 100 km circumpolar orbit to land onto the lunar surface to make MIP the first man-made object from India to land into the south pole of the moon. And this happened on 14th of November 2008. So, India had an imprint on the moon in the polar region exactly close to the poles at the Shackleton crater. How many years back? कितना हो गया? Right. So, 16 years back itself, India has touched the moon. Okay. There are a lot of science which has come out from this mission, which is described in this 240 scientific publications, including the most important being discovery of water. So, Indian Chandrayaan 1 is credited with the discovery of water on the moon. Till that time, we are not knowing water exists on the moon, though there have been landings of humans through Apollo missions. Not only that, it also told us about lunar magma hypothesis, which is now again validated with the Chandrayaan 3 missions, and also telling that moon is geologically and volcanically active. And activity in the very recent past in geological time scales of 10 million years to 20 million to 50 million years. And then of course, the detailed study of solar wind interactions and discovery of mini magnetosphere. So, there were many discoveries which is credited to the Chandrayaan 1 mission, including of course, cover pages of journal like Science, which talks about discovery of water on the moon, or Geophysical Research Letter, which talks about discovery of mini magnetosphere. This is one of those results where I was directly involved with the instrument called SARA, which discovered that the solar wind, which is plasma coming from the sun all the time, impacts the lunar surface and neutral hydrogen comes out, and that made the press release from ESA, European Space Agency, talking hydrogen offers a new way to study the moon. So, there are many new science which came out from the Chandrayaan 1 mission, and if you want to see how the surface of the moon looks like, let me just show you quickly. If it works here. Oh great, it is working. So, this is how the surface of the moon looks like. You see all the spots, these are craters. So, moon is full of craters of all possible dimensions, right from millimeter, centimeter to meter to kilometer to 10 to 100 to thousands of kilometers. क्रेटर के अंदर क्रेटर, क्रेटर के बाहर क्रेटर, इधर क्रेटर उधर क्रेटर, जहां देखो क्रेटर ही क्रेटर है, राइट? देख रहे हो सब ये सब जो है ना, ये सब क्रेटर्स हैं. क्यों? क्योंकि मून डजंट हैव एन एटमॉस्फेयर. So any body which is coming and hitting the moon will create a crater, and since there is no weathering, it will be preserved. So if you have a fresh crater, it will look brighter, but if you have an old crater, it will look darker. Depending upon the solar illumination at that position, the darkness will vary around it. I will skip this, Now going to the Chandrayaan 2 mission. Chandrayaan 2 mission was much more complex than Chandrayaan 1 because it had a lander and a rover inside it, right. And we had the launch on 22nd of July 2019. We went into an orbit around the earth like Chandrayaan 1, went to a lunar transfer trajectory, got inserted into an elliptical orbit, went into 100 kilometer orbit, went into 100 by 30 kilometer, and then did the landing on 7th September 2019 early morning 2:30. And we all know what happened, right? याद है कुछ? आप लोग शायद उस समय किस क्लास में होंगे? 7th 8th, right? अभी सब 11th 12th के बच्चे हैं, right? All are 11th 12th grade students, right? So it is about 5 years back or 6 years back. कितने साल हुए? 5 years back. तो 5 years back आप लोग छोटी क्लास में होंगे, right? And many people say that India could not land. It was a failure. But I said no. It was a big success because failure teaches you much more than the success missions. And the failure of the Chandrayaan 2 landing part has taught us a lot of things. If you look at the whole mission, it went perfectly well till almost the last leg. That means all the technologies which are developed by India indigenously within the country got validated. Of course, there were certain things which has to be corrected because that is why the failure happened, but the orbiter part is still working. For last 5 years, orbiter is still working around the moon and providing us excellent quality of data. And the instrument called OHRC, which you see over here, is the highest resolution spectrograph, or I should say camera on board on any current mission around the moon. And we use this to decide the Chandrayaan 3 landing site. So, Chandrayaan 2 orbiter has given the right amount of data and the right quality of the data to decide where we should do the landing for the Chandrayaan 3. In addition, of course, there are many other experiments on board like your TMC-2, which has given us a lot of detailed information of the Sarabhai crater. Sarabhai ji has a crater on the moon, right, named after him, and this is on the near side of the moon. It is about 8 kilometer in diameter. So, if you have a small telescope, you can actually see this because it is on the side which we are able to see from the earth. It has a dual frequency radio, dual frequency SAR, L and S band, and therefore, we are able to see beneath the surface because SAR can give you information to several meters beneath the surface of what is happening, what is the material present there. And about the hydrations, Chandrayaan 1 discovered water, but Chandrayaan 2 has given us a lot of information about the distribution of water, about the elemental composition, and also about the argon 40 distribution at the atmosphere, or I should say exosphere of the moon, because moon does not have an atmosphere. It is a very, very tenuous atmosphere which we call as exosphere. And then there is an instrument called sun, or basically solar X-ray monitor, which provide us what is happening on the sun. And why we need that? Because there is an instrument called CLASS, which you see over here, and gives us the elemental composition from an orbiter. But to know the abundance, we should know how much flux is falling on the lunar surface. And this instrument is working for the last 5 years fantastically, and this is the most, or I should say highest resolution spectrometer working in 1 to 15 kV, providing spectrum every 1 second. We will skip this. Now, let us talk about Chandrayaan 3 mission, the most celebrated one. It was similar to Chandrayaan 2, but there was no orbiter because orbiter is already there. So, what we need to take this Vikram lander to the moon, and that is why we had propulsion module and the lander, the Vikram lander, and inside the Vikram lander is the Pragyan rover, right. And this is the composite, this is the propulsion module, this is the lander, and each one of them, both the lander and the rover, have scientific experiments to do science. On the lander, we have 3 experiments: INSA, which is for measuring the seismicity; Chaste, which has gone inside up to 10 centimeter deep to measure the temperatures; and a Langmuir probe which is sitting on a top deck at a height of 2 meters from the lunar surface, providing the plasma distribution. Whereas on the rover of the lander, sitting inside the lander, the Pragyan rover, it has two instruments, APXS called alpha particle access spectrometer and LIPS, laser induced breakdown spectroscopy. And PRL is directly involved in the development of this instrument and the CHASTA instrument. So, two instruments has come out from the labs of PRL. This is the Sriharikota. You can see our launch vehicle LVM-3 or launch vehicle Mark 3, and the Chandrayaan is sitting right on the top inside the heat shield. We had the fantastic launch on 14th of July. You want to see the launch? Okay, let us see where it plays.
8, 7, 6, 5, 4, 3, 2, 1, 0. Plus 5 seconds.
Lift off normal.
Here we have a majestic lift-off of LVM-3 M4 rocket carrying India's prestigious Chandrayaan 3 spacecraft.
P2 tracking.
प्रज्वलन और सफलतापूर्ण उत्थापन LVM-3 M4 रॉकेट का यह भीम का रॉकेट आसमान को चीरते हुए अपनी भयानक दहाड़ से चारों ओर कंपन उत्पन्न कर रहा है। इसे हम यहाँ महसूस कर सकते हैं और यही दहाड़ है जो वैज्ञानिकों को रोमांचित करती है।
That is why we call it as बाहुबली।
LVM-3 के उत्थापन के साथ ही हमारे अंतरिक्ष यान चंद्रयान 3 की चंद्रमा की यात्रा प्रारंभ हो चुकी है।
As the rocket is soaring through the clear skies, every second moving closer to the accomplishment of the most important milestone in its mission to moon.
And if you are in the mission control, as I was that day, we could actually see the vibration when the launch takes place, though we are sitting about 5 kilometers away from the launch pad. And this is how the crowd comes there. So, all of you are interested to witness this launch can actually go to Sriharikota and apply online on the ISRO's website and then go and watch this. So, after the launch, like our Chandrayaan 2, we went into orbit around the earth, went to lunar transfer trajectory, went into elliptical orbit, get captured, went down to 100 kilometers circular and then 100 by 30 and we started descending. So, this is the D-Day. 14th of July was the launch, right? And 23rd of August was the landing. How many days? साइंस के बच्चे हो, राइट? फटाफट कैलकुलेट करना चाहिए, कैलकुलेटर नहीं यूज करना चाहिए। जुलाई 31st 30 डेज नहीं लगा सकते आप। भाई साहब आपसे नहीं पूछ रहे हैं। So this was the D-Day when we are all waiting for anxiously in the mission control. I was also sitting there, you can see me here, right? This is our chairman ISRO sitting here. You want to see the landing?
The sensors that are updating at this point are providing confirmation
So this is the very
of the
last
safety
part,
of the
okay?
landing site.
Hardly 2 minutes.
As expected, the retargeting is going on.
So we have
and this
completed
is a very
already,
good
come very
signature
close,
for
about
the
100
lander.
meters. You can see here 75
अभी आप ये
meters
देख सकते हैं
altitude.
कि
Prime Minister
लैंडर
was
की
there
ऊंचाई
in the
लगभग
South Africa that
65
day.
मीटर के आसपास
He was
बची
watching
हुई
us
है।
live from there, and we had 2 engines firing there. We had 4 engines on the lander. 2 were firing in the last stages.
Currently, only 2 engines are now being fired, and we are nearly at 0 velocity, vertical and horizontal.
Landing happens
we were
autonomous.
hovering, and
it
now
comes
we
like
are
this.
approaching
Then finally
the
it
moon's
becomes vertical,
surface.
and that's how it lands.
धीरे
And there is no
धीरे
command control which is given
लैंडर
from
की
anybody.
वेगमान को
It
कम
is
किया जा
autonomous
रहा है
landing decided
और
by the
हम अब
spacecraft
लगभग
itself.
50 मीटर से भी
That's why all the
कम आ
sensors
चुके
which
हैं।
are there has to work in unison to get the perfect landing. They are almost like 30 meters. And you see, these
Who is
are the ones
here
which are
to
coming to
encourage
me
us,
or to us in the
and
mission control,
he
telling
is
where we are
critically
actually
looking
on
at
the moon.
the visuals.
It is almost last stages.
जी हाँ, आप अपनी स्क्रीन पे देख सकते हैं कि हम
We have the fantastic,
लैंडर मॉड्यूल
as the command came that it has landed,
People are
everybody was
applauding.
jubilant.
Let us all wait to hear from the Secretary Department of Space and Chairman ISRO, Shri S. Somnath.
लैंडर मॉड्यूल पूरी तरह से सेफली और सॉफ्टली चंद्रमा की सतह पे लैंड हो चुका है। ये हम लोगों के लिए बहुत ही गर्व की बात है। हिंदी में एक कहावत है कि चंदा मामा दूर के, लेकिन अब हम ये कह सकते हैं कि चंदा मामा अपने घर के।
So this is what the journey is which has led us to the celebration of the National Space Day, and 23rd of August 2024 is the first National Space Day celebration. I will skip this. And so I was also over the moon celebrating myself with this model of lander and the Pragyan rover. But how the whole world was.
India has done it. It has become now the 4th country to land a spacecraft on the moon after the US and China and the former Soviet Union. Just moments ago, we're talking just a...
India has made space history, becoming the first nation to soft land a spacecraft on the moon's south pole. India has become the first nation to successfully land a spacecraft near the south pole of the moon. The country's PM Narendra Modi has praised the achievement, saying that the mission success belongs to all of humanity.
The spacecraft Chandrayaan 3 is attempting to become the first to land on the moon's south pole.
India is the first country in the world to land a spacecraft near the moon's south pole, a moment of history for the country. It was a tense final 6 minutes as it descended onto the lunar surface. Let's show you the moment. First of all, let's take
This agency is celebrating the successful moon landing of its Chandrayaan 3 spacecraft.
Okay, now India's lunar probe Chandrayaan 3 has landed on the moon's south pole. India is the first country to touch down on this part of the moon, which is believed to hold pockets.
We begin with some historic news. India has become the first country in the world to successfully land a craft near the moon's south pole. Prime Minister Narendra Modi was watching the mission from South Africa and congratulated the team back home. Let's take a closer look at what.
So this is how the whole world was celebrating the success of India, as India became the first country in the world to land very close to the south pole at 70 degrees south. But then we all in the mission control were busy to take this rover out, because our science will be done only when the rover is coming out of the lander. So the Pragyan rover, which is sitting inside the lander, has to come out, and I will now show you how the ramp deployment took place, because we were there throughout for next 12 days inside the mission control, controlling the whole lander and the rover. You see, the ramp is being deployed, and this is the first glimpses we got of the rover after our closing of the heat shields, and then the solar panel will be deployed, you see here. And because the rover is working on the batteries which is generated by the sunlight, so solar power has to be given to charge the batteries, and then only the rover will be rolled down. After this, the rover has to come out, right? So you will now see how the rover came out. What is released? See the shadow. And very soon you will see the first. Mission control, as the data was coming live, I was holding like this. Why? Because there was a crater right in the front. Right? Did you saw? No. Because only very penetrating eyes can see that. So I was holding like this, Baba, ruk jao, ruk jao, ruk jao. And it did stop as the command was given. But then later on we did the analysis to find out how deep this crater is right in the front, and then we actually pass through. So you see this crater, right? And if this crater is deep, it will engulf or it will give hurdle to one of the wheels, it will get stuck. So we did lot of analysis because the rover stopped right here, and after that we said no problem, it will go through, it went through. So this is how we were actually commanding and controlling for every movement for few meters, and then taking images in the front, seeing what is there, and then deciding the further movement. So then, how hard? I will tell you about this later. We saw this big crater. अब तो भाई नहीं हो सकता है, ये रोवर इसमें गया तो पता नहीं निकल के आएगा कि नहीं. So we decided no, we have to come back. So we retreated back. You see the wheels making what you called footprints of the rover, and this is the footprint of Indian Pragyan rover on the lunar surface. Okay. Then the Pragyan rover took the selfie of the lander. तो लैंडर बड़ा भाई है, प्रज्ञान छोटा भाई था, उसके साथ बैठ के गया, right? It got established on the landers on the lunar surface, and now this Pragyan, the small 6-wheel fellow, has moved back and seen how are you, and that is how it sent this selfie of the Pragyan rover, of the lander, and this is actually an iconic picture, I should tell you. This is a proof that where we were sitting and where the Vikram lander is actually sitting and how the Vikram lander is. Later on, we deployed all the instrument. You see ILSA sitting there on the surface, Chaste gone inside 10 centimeter, deployed, and the Ramba LP, which was actually a Langmuir probe, which was deployed like this 90 degree to the lander's top surface. All three were done, and they were all working very well for 12 days. Now we know that this landing site is called Shiv Shakti, right? Isn't it? But we have also named the point where the Chandrayaan 2 lander landed, and it is called Tiranga Point. This is more famous, of course, right? And this is named not by India. It was India's suggestion accepted by International Astronomical Union, which finally named it on 19th of March this year. Though Prime Minister announced it 3 days later on 26th of July or August, 26th of August, but finally International Astronomical Union has accepted this name as Shiv Shakti, and therefore the India's Chandrayaan 3 landing site is worldwide now known as Shiv Shakti Point. Now this Pragyan rover is meant to do job, and it was moving around taking observations, then moving, stopping, making observations. Now you will see here how this is Bada Bhai taking photograph of the it's like a toy moving, right, on the surface, and it is the moon, not on the earth. So you have to command and control the whole spacecraft from the mission control to the lander. Lander sends the signal to the rover, rover acts, send back the data, and that's how it continued for next 12 days. So the rover was moving, it went into this, saw a big crater, came back, it went in this direction. Then the scientists who were sitting there were also deciding what to do, which site to explore. And they said, no, we should go in this direction, because this was a fresh crater. And therefore, we went into this direction, made lot of maneuvers here, went very close to this crater, and then finally, this is our place of residence now of the Pragyan rover, whereas the lander is sitting here at the Shiv Shakti point. We all know that there are 6 experiments on the lander, rover, and 1 on the propulsion module called SHAPE. And what all they have given is given over here. So if you look at ILSA, which was a seismometer, so it was giving signals whenever rover was moving onto lunar surface. That means you can actually correlate the vibrations on the lunar surface by the rover movement, and that can tell you a lot about what kind of surface this moon surface is. Similarly, your Ramba LP gave us information about the plasma distribution at a height of 2 meters from the lunar surface. And Chaste, which was like a thermometer with 10 sensors sitting on the 10 centimeter, and all have gone inside, providing us temperature at different heights. Why we require that? We wanted to know how the heat is going inside. Why we want to know that? Because it is known that the lunar surface is highly non-conducting, and therefore we should know how the heat is actually going inside and whether it is going inside or the heat is actually coming from outside, from inside out. This one, if you look at the temperature plotted here with depth, this is millimeter. Within 10 centimeter, there is a drop of almost like 50 degrees centigrade. That means it is highly non-conducting. And if you look at carefully, there is some slope changes. That means even the top 10 centimeter, there is a gradient or there is a change in the conductivity. So after getting this kind of data for the first few days, we said after the 10 days, there was a heater inside on this probe which went inside, and we started the heater to do actual heat conductivity measurement for the first time. And that has told us that yes, the conductivity is absolutely very low, and it is really low than what we were actually anticipating. And that is the first conductivity measurement in the first 10 centimeter done by any mission so far, not even Apollo missions. Because Apollo mission, what happened was, men or humans went there and they did the drilling using actual drillers. So they went 1 meter, 2 meter deep, but nobody was bothered about the first few centimeters. And it is also very important, if we have to think about habitat on the moon, that this soil is highly non-conducting. So this can actually be used as a thermal shield, and that information is now available to us. LIPS, which is a laser induced breakdown spectroscopy experiment, provide us a lot of information about elemental composition. You can see here the elements present there, including the metallic ions. And the APXS, alpha particle access spectrometer, has provided us the first information about the elemental composition at the lunar near the Shiv Shakti point. As the rover was moving, I will show you this one. This is the rover. In the front was the APXS, alpha particle access, and every time it has to be deployed like this, and it comes down, make measurements, comes back, and then how the rover was moving. And if you want to see how that's happening, just see it here in this mode. Operation of alpha particle access spectrometer. See this, rover is stopping, plate is coming down, it will be here, rover will be standing for a few hours, then plate will go up, then only rover will move. So this was done at 30 different points. As you saw that, how the rover was moving around the landing site, we made such measurements using this alpha particle access spectrometer. And that is how this is the first measurement of elemental composition at high latitudes, and that is why this has come in the Nature. It came yesterday only out. You can see 21st of August. And what it has showed, that in addition to major elements like silicon, aluminum, calcium, magnesium, iron, minor like titanium, sulfur, chromium, manganese, nickel, potassium, sodium are also present there, though their percentage is less than 1%. So this is how the sophistication or the calibration of this instrument was, that we could nail any abundance of any minor element also on the lunar surface whose abundance is around 0.1% or low. And this is how you see the composition looks like at this landing site. Oxygen, of course, all are oxides, so they are minerals, but then the dominant is silicon, then aluminum, then calcium, magnesium, iron, and then all these minor fellows, which is about 1%. Now what is the importance of this? Importance is how this elemental composition different than other compositions measured by Apollo or Luna, and whether it tells something about the history of the moon. And in the paper we have told, yes, it is validating the lunar magma hypothesis, but the abundance of magnesium, which you see over here, is higher. Magnesium is a heavier element, right? So when there is a kind of magma, the lighter fellows will be floating, the heavier fellows will be settling down towards the center of any planetary body. So there is a differentiation. So the crust will be formed by lighter fellows, and the mantle and the core will be formed by the heavier fellows. If we are seeing higher magnesium, that means inner material has come out at the landing site. And that we suggested that it is only possible because there is a South Pole Aitken basin. A basin means a big crater, South Pole Aitken crater, which is the biggest crater in the solar system, and it is only on the moon in the South Pole, and which was also discovered very recently when the Galileo actually passed through. The Galileo was an orbiter, was a spacecraft sent to the Jupiter, but when it was having a flyby, it saw there is a huge crater which nobody has noticed. It is slightly on the far side of the moon, and that must have thrown material because it is about 8 km deep crater, and therefore it is exposing inner material to come on this landing site around where the rover has made the measurements. And there are many other things which has been told in this paper. One can go through this. Okay, I will skip this. Now, I was very fortunate to have this model of the rover, which was there during the mission, and it was displayed outside. So, I thought it is good to have a movie, to have a photograph, and you see here this is a plate and this is our AP axis. Every time the plate was put down and the measurement was made, this is 1:1 model of the rover, exact replica in terms of dimensions, and back you are seeing is the lander. So, there was 1:1 model of the lander and rover and of APXS, and therefore, I thought it is the best place to have this kind of picture. Now, after the mission was over, because mission was only one lunar day, एक lunar दिन, एक lunar दिन बराबर है 14 earth days, right? Isn't it? Clear? बहुत लोग सो गए, नहीं रिस्पॉन्स ही नहीं आ रहा, ऊपर वाले तो और भी सो गए, ऊपर वाले सो रहे हैं क्या, जग रहे हैं, अच्छा ओके ओके। तो आपने देखा होगा कि मून का एक ही हेमिस्फीयर हमको दिखाई पड़ता है, क्यों? पीछे का हिस्सा नहीं दिखता कभी हमको अर्थ से, ऐसा क्यों होता है? एनीबॉडी? स्टूडेंट्स ओनली, टीचर्स या अडल्ट नहीं? हाँ बताइए, किसी ने बोला कुछ अभी? रोटेशन नहीं होता, ऊपर से कोई, ऊपर वाले देख रहे हैं, ऊपर वाला सब देख रहा है आप लोगों को भी, हैं? अर्थ और सन की क्या डिफरेंट होती है? रोटेशन। अभी तक इसका मतलब फंडामेंटल्स क्लियर नहीं है आप लोगों को कि हम okay, perfect. Now let us assume that this is moon and I am the earth, okay? So I am looking at this face, I am the earth, okay? Now this fellow I am spinning, अर्थ कितना टाइम लेता है अपने एक्सेस पे? 24 आवर्स में, राइट? तो 24 आवर्स में मून कितना घूमता है एक दिन में? 360 डिवाइडेड बाई कैलकुलेट करो। सिंपल कंसेप्ट बताते हैं, अर्थ को अपनी एक्सेस पे 24 घंटे में लगता है टाइम, राइट? मून को लगता है 28 डेज, राइट? तो यानी कि अगर मून को अपनी एक्सिस पे घूमना है और अर्थ का भी ऑर्बिट लगाना है, वो दोनों अगर सेम होंगे तो एक ही साइड दिखाई पड़ेगा। अर्थ पे दिन रात होती रहेगी, ओके, बट फेस जब भी देखोगे मून का एक ही दिखाई पड़ेगा। क्यों? क्योंकि मून ऐसे है, whenever you are roaming it will be always facing earth like this। अभी एक चक्कर लगा लिया ना इसने अर्थ का, बट ऐसे ही देख लिया। So this side is one which is called near side, the side which we see from earth, and the other side is called the far side. So we are not able to see the far side of the moon, and that is why South Pole Aitken Basin was not known in spite of human landing on the moon. It was only discovered much later. Now, one more experiment which we did after the mission was over, which was only one lunar day, that is 14 Earth day, that our lander has landed, there is a propellant there. Can we start the engine again, do a lift from the moon, which was not planned mission, it was not part of the planned mission, but we thought in future we have to do sample return mission, means we have to land and then lift off from the moon. So, why can't we do this experiment with this? Of course, there are a lot of things inside when you take this kind of technological discussion, that what is going to happen, suppose it lifts off and topples down, suppose communication breaks down, suppose it does not fire, lot of ifs and buts are there. We did all those things and then finally decided no, let us try, and we did the hop test, that is why it is called hop test. So, this is how, क्यों हिल रहा है भाई, पहले से हिलने लग गया है, कुछ उसको हॉप पहले से मिल गया. ओके, सो ये आपको दिख रहा है, स्टार्टिंग में याद है आपको, ये रैंप डिप्लॉय किया था हम लोगों ने, राइट. सो दिस इज द पिक्चर बिफोर हॉप, मीन्स आफ्टर लैंडिंग दिस इज व्हाट द पिक्चर इज. आफ्टर हॉप वी हैव, ये क्रेटर याद है ये वाला, अभी हमको ये वाला भी दिख रहा है, क्यों, क्योंकि हमने हॉप करने के बाद दूसरी जगह पे लैंड किया. सो वी फायर्ड द इंजन, we lifted almost like 40-50 centimeter, moved little bit ऐसे और बैठ गए. But it was a big achievement for India, because we can fire our engines on the lander after 12 days of landing, because this is done on night of 2nd and 3rd. It was midnight of 2nd, early morning of 3rd. You want to see how it was? Let me see, hopping. ध्यान से देखिएगा, it is a imager on the lander which has, अभी रैम नहीं दिख रहा है, फोल्ड हो गया. Started, dust is coming out, there's a lot of dust in the floor. Very soon you will see this. Yeah, main firing, and after that landed. See the shadows. And clean. Now this experiment also has given us a lot of information about this surface properties. That means dust has no issues. Dust settled completely. Within seconds of landing, dust is also settled. Earlier we were all worried about dust implications, and when the landing will take place, it will take few hours for dust to settle down, because dust is levitated, dust is charged and things like that. But at this position of 70 degrees south, we do not see this. That means this has different properties compared to previous landing sites. In addition to this, we did another experiment. The propulsion module, which was in orbit around the moon after it has released the lander, was moving in the orbit. So, we have Chandrayaan 2 orbiter and propulsion module, both are moving in the orbit around the moon. After few months, we decided that we should bring back this propulsion module back to Earth. Why? If we have to do sample return, then the sample has to be brought up into an orbit around the moon, and from there it has to be brought back to the Earth's orbit. So, we did this experiment, we took this from orbit around the moon into an orbit around the Earth now, and this is done after 4 months. That means somewhere around December, January of this year, we did this experiment of how we can bring back any module which is there in orbit around the moon to an orbit around the Earth. This is all for preparation of the next mission of India. So, what next? We are now working on a mission with JAXA, that is Japan. It is called Indo-Japan mission or ISRO-JAXA mission, to go into permanently shadowed regions. Now, what is permanently shadowed regions? जहाँ पे लाइट नहीं आता है, ये देख रहे हैं, ये क्रेटर है कहाँ पे 89 डिग्री, 89.4, मतलब राइट एट द पोल. मून जो है ना, पृथ्वी ऐसे है ना, राइट 23.5 डिग्री, इस पे लाइट दिख रहा है, ऐसे दिख रहा है. तो अर्थ जो है 23.5 डिग्री टिल्ट होकर के सन के चारों तरफ घूमती है, राइट. मून है वर्टिकल, उसका टिल्ट है 1.5 डिग्री ओनली. तो अगर यहाँ पे कोई पोल्स पे क्रेटर हैं, they will never see the sunlight because photons move in straight light, right? तो यहाँ पे क्रेटर देख रहे हैं, ये पोल पे है 89.44 राइट एट द पोल, इसमें कभी सनलाइट नहीं आएगा. अगर सनलाइट नहीं आएगा, टेम्परेचर गोज डाउन टू समथिंग लाइक 50 केल्विन, 30 केल्विन, -250 डिग्री सेंटीग्रेड. यू कैन इमेजिन, राइट? तो क्या हो गया, ये पोल्स के जो क्रेटर्स हैं, दे बिकम ए डी फ्रीज, परमानेंटली फ्रीज्ड. So any volatiles including water, if they go and sit there, they will be sitting there for ages. They cannot come out because they don't have energy to come out. Temperature is so low. And that is why our interest is to go and explore those regions to know what is there. And these are the locations which are believed to have much more amount of volatiles including water. So if future exploration has to take place, we need water for humans, right? And therefore, we should know how much water is there in these polar regions, particularly permanently shadowed regions, जहाँ पर कभी सनलाइट नहीं आता है. बट उसी के आसपास आप देखिए, जैसे अब ये पोजीशन देख रहे हैं जहाँ पे हम लोग CR1 करके बोल रहे हैं, ये ऐसा रीजन है जहाँ पे हमेशा सनलाइट रहेगा क्योंकि थोड़ा सा एलिवेटेड है. सो वी नीड टू लैंड at a location where sunlight is there because we need to charge our batteries, but we should be very close to a permanently shadowed regions. And this is how this challenging mission is being taken by ISRO and JAXA, where the launcher and the rover will be from JAXA, the lander will be from India. So जो लैंडर है, जो चंद्रयान 2 लैंडिंग ने दिखा दिया, उसकी वजह से जापान चाहता है कि हमारे साथ मिलके इस मिशन को किया जाए. इंडिया और जापान मिलकर करते हैं, और जिसमें कि लैंडर इंडिया से होगा, लॉन्चर जापान का होगा और रोवर भी जापान का होगा. बट रोवर पे एक्सपेरिमेंट्स जॉइंटली इंडिया के होंगे और जापान के होंगे. सो इट्स ए म्यूचुअल एक्सपेरिमेंट बीइंग कैरिड आउट टू एक्सप्लोर व्हाट इज देयर इन द परमानेंट शैडो रीजन्स. एंड इफ यू लुक एट दिस मिशन, दिस इज गोइंग टू बी ए मिशन ऑफ अबाउट 3 months. Landing will take place around this location. For example, this is the one of those places where we have identified we can do landing. Rover will come out, go into this, come back, get charged, and after charging again go into some other crater, come back, charge, again go to another crater, come back, charge. So like that, there is a lifetime which is decided for the rover of about 3 months, but it is expected probably if things goes well, it may last for longer. And therefore, this mission will be again going to create a history because nobody has explored the polar regions and particularly permanently shadowed regions. And this is all work which we are doing of where the landing should take place, how much sunlight is there. These are the regions which we are exploring and trying to understand what is expected there, right. Other one is talking about future. And the future one is of course the Chandrayaan 4 mission, which is a sample return mission. That means we have to bring back the samples from the moon to the earth to do analysis and to explore it much more detail. The reason behind this is that when you send any instrument on a rover or a lander, it has limited capabilities, limited in terms of mass, power, and therefore, since the resources are limited, you cannot have a highly sophisticated instrument sent. But if the sample comes back to the earth, in the labs we have highly sophisticated instruments and we can use that to understand it much better. And therefore, the next mission is a sample return mission, which is likely to be Chandrayaan 4 and probably Chandrayaan 5. And then there are series of missions which is being planned, Chandrayaan 6, 7, 8 and so on, till human landing happens, which is likely to happen in 2040. So India is going in a big way exploring the moon for next several decades, and therefore all these children who are sitting there have a good chance to go to the moon, right? नहीं समझ में आया? आ गया? Because you are now young. हम लोग जैसे नहीं जा सकते, राइट? वी आर एजेड, वी आर बी डिस्क्वालिफाइड एज एस्ट्रोनॉट्स, राइट? We need fresh blood, young minds, brilliant minds to go and explore the moon and be the first person to land from India onto the moon. It is likely to happen in next 2 decades, and therefore it is your responsibility to take up this kind of challenges. And it is not the end. If we have reached there, what next? We should have habitat on the moon. And I can assure you, time is not far away. In next few decades, you will see human habitat on the moon. It is bound to happen, irrespective of anything else. And it is also required for humanity. You know, it is also required for humanity. Why? If something happens on the planet Earth and humans are wiped out, what is going to happen? We should have human species somewhere else in the solar system, and the best place is moon, because we have seen what has happened 65 million years back, correct? Dinosaurs got extinct simply because a huge asteroid came and hit Earth, and therefore because of this changes which happened on the planet Earth, the big animals died completely, wiped out. So, if we have to preserve the human race, we have to come out of the planet Earth, and therefore it is always said that Earth is a cradle for mankind, but mankind cannot remain in cradle forever. It has to come out, and therefore you will see very soon habitat on the moon, and once habitat is there, you will see exploration happening from the moon. So, moon can be used as a base. It looks like a fantasy, right? अभी लगता है ना कि कहानियों वाली बातें हो रही हैं, नहीं, कहानियों वाली बात नहीं है, ये यथार्थ में बदलने वाला है, because technology is progressing very fast, unbelievably fast. The only thing which is limiting us right now is the energy required to come out of the Earth's gravity. Because if you have to come out of the Earth, you have to spend a lot of energy, and that is why you need big rockets, huge fuel, lot of propellant, mass, rocket, to what? Just working against gravity. Simple physics. Physics पढ़ते हो ना सब लोग? Simple physics है, G के अगेंस्ट जाना है हमको, उसी में सारी एनर्जी चली जाती है हमारी. If any one of you come out with an idea of how we can do this with less amount of fuel, with less amount of energy, days are very near that we can actually go to the Mars, and of course human is going to go to Mars very soon. Only problem in the Mars is, right now with the technology, the travel time is very large. Moon we can go and come back in 1 week, 2 weeks, few weeks, right? But Mars, 6 months, because the travel time is large. So one way is नहीं है ना, 2 way means 1 year हो गया. ऐसा तो नहीं 1 way भेज दिया उसको, जाओ वहीं रहो अभी, टाटा बाय बाय, उसको बुला के भी लाना ना, वापस भी लेके आना. Like currently we are seeing Sunita Williams in ISS, right? Stuck there because of issues. Sunita Williams, right? So we have to have modus operandi to bring back the humans from moon as well as from Mars, and therefore there is a rich what? Opportunities available to all of you to come into the area of space exploration, because it needs people from all branches of science and technology. Don't think that I am a physicist, I am a mathematist, I am a chemist, I am a biologist, I am a medical person, I am a law person, I am a management person, I am a businessman. Everybody is required here. Now we are talking about space laws. There is huge work which is going on about laws to understand what, who, why, and therefore there is a lot of space laws being written. People working in the area of medical, because astronauts are going there. So we have a space medicine, we have space food, and very soon space tourism, right? So space, anything on the planet Earth, you add space to it. So anybody working in any field, even sociology, psychology, how the psychology of the astronaut changes when it goes in isolation. You need people, right? 5 minutes? Okay. So therefore, you choose anything which you want and do it well, and just add space to it. You can work in space science, because people from all walks of life, including space music, and probably there may be space sports in future, right? Once the human start living on moon, there can be Olympics on moon also. Somebody was talking about that also very recently when Paris Olympic was happening, that when we will have Olympics on moon. So that means people are thinking about it, and probably we can have LTC to go to moon, right? Isn't it? So instead of going within the country, India will say, okay, India will sponsor you to go on LTC to moon, right? But of course it has to be two-way ticket, not one way. So there are ample opportunities for everyone to actually contribute the way you want to do. It is only a matter of thought, or the way you think you can contribute. So with this, I would like to thank you all for listening patiently. I will skip this, and thank you very much. Thank you.
Thank you so much, sir, for captivating all of us with your wisdom. And it has been an amazing lecture, as you have given the in-depth analysis of Chandrayaan 3 and the future aspirations of Indian space missions as well. So with this, I now request Professor V.M. Tiwari to please moderate the question hour session, which would be present now in front of our chief guest. Yes, sir, mic. Can I request the microphone?
You can use this one also.
So we are really mesmerized by all of yours journey from Mother Earth to Chanda Mama, and I am sure that there may be a lot of questions, but whatever you think which is very critical to get you involved in the Antariksh program of ISRO or India, those kind of questions are only to be asked, and I request all our senior colleagues, please abstain for the question and for you can interact during the lunch time. So only school children and the students who are pursuing science and they are excited about knowing about the space exploration, please raise your hand, and we will be giving you mic so that you can interact with our chief guest. Please, any one of you.
ऊपर से कोई है? I am able to see you now better.
आप लोगों को कोई पूछना है? नहीं? ठीक है.
अगर आप लोग नहीं पूछोगे तो मुझे पूछना पड़ेगा.
गुड मॉर्निंग सर. सर मुझे एक चीज़ पूछनी थी कि जो मिशंस होते हैं वो इतने शॉर्ट टर्म क्यों हैं, और मतलब दूसरा क्वेश्चन भी है. पहले सर वो पहले क्वेश्चन
पहले वाला चलो. शॉर्ट टर्म डिसाइड करता है कि आपका ऑब्जेक्टिव क्या है, आपके रिसोर्सेज क्या है. इफ़ यू फॉर एग्जांपल मून मिशन जो हमारा था वो 14 डेज़ का था, बिकॉज 14 डेज़ का दिन 14 डेज़ की नाइट, जब नाइट होता है मून पे टेम्परेचर बहुत लो हो जाता है, एंड पर्टिकुलरली पोलर रीजन्स में जहाँ पे हम लोगों ने लैंडिंग किया अराउंड 69.37 डिग्री साउथ, वहाँ पे जो टेम्परेचर नाइट में -200 के नीचे जाएगा. So that means it is very difficult to survive unless until you have a source for keeping you warm. Since sunlight is not there, what is the source? There is no source unless until you carry some other source like nuclear powers kind of thing. And therefore, the mission lifetime is now decided by the resources which is available. But you see orbiter, Chandrayaan 2 का orbiter अभी 5 साल से orbit में है because it is working. It has resources, sunlight is available to the orbiter. It is working very well. I will tell you one example. मंगलयान का नाम सुना है? क्या है? Mars orbiter mission, right? It is the first Indian mission to Mars, and it made India the first country in the world to have the successful insertion of an orbiter around the Mars in the first attempt. But उससे ज़्यादा क्या है? Its lifetime was only 6 months. It worked for 8 years. 8 साल तक काम किया, 6 महीने का लाइफ टाइम था उसका. So we keep the lifetime according to that our science objective will be fulfilled and based on many other parameters on which we decide the lifetime of a mission. But it can work more longer and it works. Okay.
सर सेकंड क्वेश्चन इज जैसे वॉयेजर 1 में हमारे प्लूटोनियम को एज अ रिसोर्स यूज़ किया गया था क्योंकि जितना दूर जाएगा तो सनलाइट भी उतनी कम होती रहेगी, तो हम ये मार्स मिशन में मार्स मतलब मून मिशन में जैसे डार्क साइड पे जा नहीं सकते, तो वहाँ पर ऐसे रेडिएशन को रेडियो एक्टिव मटेरियल यूज़ क्यों नहीं कर सकते एनर्जी के लिए?
कर सकते हैं, बट देयर आर अदर लिमिटेशंस ऑन दैट. फर्स्ट ऑफ ऑल यू शुड हैव दैट. ओके, कंट्री शुड हैव, isn't it? Nobody will give you. So you have to develop this landing technology. Nobody has given to India, right? We developed our own landing technology. So there are many things which are strategic in nature, which the country has to develop of its own. Nobody is going to give you.
मतलब फ्यूचर पे तो देख ही सकते हैं.
फ्यूचर में कर सकते हैं. We are also doing those things.
अब आपका समय समाप्त होता है, हम लोग दूसरे क्वेश्चन पे जाएंगे. और anybody else? और
बगल में दे दो.
लड़कियों का भी ध्यान रखिए, इन लोगों को भी पूछना है. आइए. ठीक है, आप पूछ लीजिए.
सर एक स्टार्टअप है जो कह रहा है कि हम 3D प्रिंटिंग करेंगे स्पेसक्राफ्ट की, और क्या ये पॉसिबल है? और अगर पॉसिबल है तो स्पेस साइंस एक्सेप्ट क्यों नहीं कर रही जल्दी?
आप किस क्लास में हैं? 12th में. ओके, बहुत अच्छा प्रश्न पूछा आपने. 3D printing is getting done for anything and everything. Okay, 3D printing क्या है? आप जो CAD मॉडल होता है जो हम लोग यूज़ करते हैं एक्चुअली फॉर मेकिंग द थिंग्स, इट इज़ डन यूजिंग ए प्रिंटर. ओके, वो लेयर बाय लेयर बनाता है. इट इज़ पॉसिबल एंड इट इज़ बीइंग डन, एंड उसके द्वारा बनाए हुए क्या कहते हैं आपको पार्ट्स स्पेस में यूज़ होने लगे हैं. ऐसा नहीं कि नहीं है. ओके, वो डिपेंड करता है कि क्या है. फॉर एग्जांपल अगर आपको मेटल का जरूरत है, मेटल जैसे एल्युमिनियम है, राइट, तो 3D प्रिंटर एल्युमिनियम को तो लेके प्रिंट नहीं कर सकता है. उसको फ्लूइड में चाहिए या एटलीस्ट सेमी फ्लूइड मटेरियल में चाहिए, तभी वो प्रिंटिंग कर सकता है. तो मटेरियल का इश्यूज है अभी, बट मैनी अदर मटेरियल जैसे कंपोजिट्स है, इट इज़ एबल टू डू 3D प्रिंटिंग एंड इट इज़ बीइंग यूज्ड. ऐसा नहीं हो रहा है. उसके ऊपर एक्सपेरिमेंट्स हो रहा है. उसको स्पेस में ले जाके क्या उसके ऊपर प्रभाव पड़ रहा है, बिकॉज देयर आर मैनी थिंग्स विच वी डोंट फोरसी और वी डोंट एक्सपीरियंस ऑन द अर्थ विच विल बी एक्सपीरियंस ओनली व्हेन ए मटेरियल इज सेंट टू स्पेस, राइट, बिकॉज टेम्परेचर्स, नो एटमॉस्फेयर, वैक्यूम कंडीशन, G different. So there are things which has to be understood of how this material will behave and how this developed subpart will behave when it goes into space. Once it is proven, it will be used.
Okay. So let us have one question from the senior colleague, teacher. Madam, बताइए.
I just wanted to ask about what kind of surface we have otherwise, on how hard is the surface where the rover
surface is not hard at all. You must have seen the prints of the rover, right? So जब भी हो सकता है, जब आप जो surface आप देख रहे होंगे वो थोड़ा क्या कहते हैं उसको, सॉइली बालू टाइप का होगा, बट बालू अगर होगा तो वो फॉल बैक कर जाएगा, इम्प्रिंट नहीं रहेगा. तो इट इज लाइक ए स्टिकी मटेरियल बट नॉट वेरी स्टिकी and relatively having a sufficient cohesiveness so that it retains the structure. That's why you are able to see the prints of the rover, right? Wheel जो निशान देख रहे हैं
गीली मिट्टी जैसे.
हाँ, गीली मिट्टी, बट गीली मिट्टी नहीं है, पानी नहीं है वहाँ पे, है इतना ज़्यादा, वो मत सोचिए. It is other properties of the material or the surface which you call regolith present there which makes it to happen. तो इससे भी साइंस हो रही है कि वो स्ट्रक्चर कैसा है, कितने दिन तक रिटेन करा, क्या उसको लैंडर ने जब देखा पहले दिन और लास्ट दिन उसमें कुछ चेंजेस आ गए क्या. देयर लॉट ऑफ साइंस व्हिच इज हैपनिंग.
सो वी विल गो अपस्टेयर्स, गर्ल फ्रॉम द अपस्टेयर.
ऊपर से.
हेलो सर.
या
हेलो.
या गो अहेड. पास.
माय नेम.
हाँ बोलो बोलो.
My name is Soha Shadab and I'm from Andhra Education Society, and I want to ask, with all these missions, what are the benefits that Indian individual is getting?
Now, space science and space technology is pervasive in our life every day, right from morning when we get up till we sleep. You know how? Your channels, your mobiles, your ATMs, and now your car driving, including GPS. Everything is controlled by what? Space science and technology. You cannot draw a cash if ATM is not working, right? You cannot transfer money sitting at your home online. Space technology is not there. That's what I'm telling. Space technology is such a pervasive technology right now, nobody realizes it. Okay. So it all has come. Why? Because there was a lot of work which was done in the last 50, 60, 100 years. And that's how we have satellites now which are helping you to do this. Right? So space science and space technology has lot of implications. Not only this, what you are seeing in your everyday life. The technology which is developed is used in many other ways. For example, I will give you a simple example. The material which we need for space to fly in space has to be hard, solid, but very light. So these are two contradictory things. If a material will be hard and stiff and strong, it will be heavier. But हमको उल्टा चाहिए, कठोर भी चाहिए और हल्का भी चाहिए. So that means there is a lot of work which is carried out in terms of material technology, metallurgy. Composites are coming now, and they are used where? In artificial limbs, in hearts, heart transplants में जो artificial hearts लगाते हैं. So there are technology which is coming out as a spin-off of the space technology, but used in many other ways. Okay.
Thank you, sir.
So I think we need to close because of the time constraint, and we will have the other agenda as planned.
Thank you, sir, for marking this spectacular afternoon with your gracious presence and inspiring the young audience. As it was rightly said, चंदा मामा अब दूर के नहीं, चंदा मामा अब हमारे घर के हैं. So thank you so much. Now I request Professor Virendra Mani Tiwari to present the honorary token of gratitude to the esteemed chief guest.
Oh boy.
Material.
Thank you so much.
In the silence of the vast space, India's dream took flight. Chandrayaan's journey touched the lunar light. From Earth to Moon, a story told of courage, wisdom, and perseverance bold. With this, I now invite Shri Ramesh Kumar Malhotra to present the vote of thanks.
Good afternoon, all of you. Thank you is such a prayer that cannot be seen or touched. It must be felt by heart. I feel honored and privileged to get the opportunity to propose a vote of thanks on this special occasion of this celebration of National Space Day at INSA. I would like to thank the esteemed speaker of today's session, Professor Anil Bhardwaj, for finding out time from his busy schedule and coming here in INSA for the lecture. I also thank Professor Ashutosh Sharma, INSA President, Dr. V.M. Tiwari, Vice President, INSA, dignitaries on dais, school and delegates who grace us with their valued presence. I also want to thank all of my colleagues in INSA who worked very hard to make this program a grand success. Especially, I want to thank Dr. Brajesh Pandey, Executive Director, Shri Sunil Jokarkar, DD1 FNA, Mr. Aditya Pilania, Section Officer, Dr. Sudhanshu Agarwal, AD, Shri Madhvinder Narayan, Shri Kartikeyan S. I would also like to thank Shri B.K. Rajput, Shri Jagdish Kumar, Ms. Preeti Kaitwas, Ms. Tarika Malik, Ms. Risha Sharma, Ms. Madhvi, Mr. Virender, Mr. Rakesh, Mr. Atri Malik, and Ms. Ananya for their continuous contribution. If I miss any other name, please forgive me. But I would like to say words are not enough to thank their constant guidance and support to shape this lecture. Again, many thanks to all of you for your kind presence and time. Thank you. Dhanyavad.
I now request everyone to please stand up for the national anthem.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मागे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
I now request the distinguished dignitaries and the audience to please accumulate outside the main building near the staircase for group photograph followed by refreshments. Thank you.